Yes, sir.
So the induced EMF in secondary coil divided by induced EMF in primary coil is equals to number of turns in secondary coil divided by number of turns in primary coil. So number of turns increases, then induced EMF is also, everybody. Number of turns increases, then induced EMF is also what, everybody? Speak loudly. Induced EMF also increases. So this is the most valid relation. So always valid relation regarding the transformers. So step up or step down doesn't matter. So that is what is true. So please remember. Now we will go for step up. So step up, primary coil or secondary coil, we'll discuss now. So step up. Step up means what? Low voltage to high voltage or high voltage to low voltage? Everybody. Step up. Low voltage to high voltage means induced EMF in secondary coil is more than the induced EMF in primary coil. Means number of turns in the secondary coil must be greater than number of turns in primary coil. Is it okay, guys? Everybody?
Sir.
That is what. So same way step down. Step down means what? We have to decrease the voltage or increase the voltage? Everybody? High voltage to low voltage means induced, understand, EMF in secondary coil must be less than primary coil, means number of turns in the secondary coil less than primary coil. So means who is greater? Primary coil induced EMF is more and number of turns also more. That is what step down transformer. Is it okay, guys? Please respond. Yes? All of you? Yes. So if I consider ideal case, of course, there is no ideal transformer. If I consider ideal case, you can see. So 100% efficient it will be there in the transformer so that whatever the input power, so power input, if it is the ideal case, so power input is equals to what will happen? Everybody, power output will come. So we all knows, but it is not existed in real life. So I can say, so power input, what is the power formula? Power formula P equals to V into, everybody should respond. Power is equals to V into what, guys? Arey yaar, power formula ra. Power P is equals to V into I. Is it right or wrong? So power input is equals to EP into IP. Same way, power output is equals to ES into IS. Emra, no response ara. That is what. So from this I will write it. So induced ES by EP, which is equals to, check it everybody, EP. So which is equals to
IS by IP.
IP by IS. Is reverse. Understanding, Vanya? So it is reverse. IS is coming this side, EP is coming this side. It is reverse. Do you understand, girl? So from this I can say, see that everybody. So EMF. So have you noticed it? Power input, potential difference and current. What is the relation? So induced EMF increases, current is decreases. Understanding? So both are okay. So and EI, if I remove the proportionality, then EI is equals to remains what? Remains EI is equals to what, guys? Constant. Understanding? So that is what. So very, very important relation. So if we increase the voltages, so current is going to what? If we increase the voltages, from this what I can say? If we increase the voltage, then current decreases. Current decreases, and same way current increases, then voltage what is going to happen? Everybody decreases. Understand, Ra? Rudresh, brothers, that is what. So ES by EP, which is equals to NS by NP, but it is ulta. IP by IS. That is what you have to remember. Current in primary coil divided by secondary coil. Is it okay, everybody? So most important valid relation for solving the numericals. Any doubt, please let me know. Okay, guys. Mr. Sai, Kevin, do it.
Yes, sir.
Yeah, please. Understand, Princey? Notice? Yeah, do it.
Yes, sir.
So voltage increases, current decreases, and current increases, voltage increases. That's what. So both vice versa. That is what you have to remember. Okay, everybody. Any doubt? Ask me. Do it fast. Okay, completed? All of you? Yes, please. That is what. Okay, Ra? Everyone? Yes, that is what. But this is for what? Remember that. So the formula what we are writing, this is for, so which is always true. So always valid is ES by. So ES by EP, which is equals to NS by NP. So which is actually always valid. But if you take ES by EP, which is equals to IP by IS, so this is actually exactly for ideal case. So ideal transformers only. So ideal transformer, this is true. But if it comes to the practical, so practical always, see, ideal transformer input power is equals to what? Power input is equals to, speak, respond everybody. Power input is equals to power output. But in case of practical transformer, please remember power input is not equals to power, everybody, power output. Okay, so always remember power input must be greater than the power outputs. Though this is what is always true. And always remember power input is greater means power output is less. So means there is something chances. What is that? Loss of? Yes, please. There is a loss of power. Is it right or wrong? Please respond. So there is a loss of power always. That is what is the true. So because of something, so whatever, maybe many reasons are there, we'll discuss it. So EP into IP is always greater than ES into S. So input power must be always greater than output power. So that is only always, actually practically it will happen. That is only the true. So subscript you write it. Don't write side so that you will get confused. So subscript it is IS. Okay. And what is the efficiency of a transformer? So efficiency, okay, eta. So efficiency is equals to, remember, so power output divided by power input into 100. Okay. So power output is what? Everybody. Power ES into IS divided by power output is EP into IP into 100. So this is what is the efficiency of the transformer formula. Okay. All of you clear? Any doubt? Anybody can ask me. Understand, brothers? Mr. Kevin, Monish?
Yes,
Yeah, please.
sir. Yes, sir.
Sai understands, Sai? Murali?
Yes, sir.
Do it and learn. Anything doubt you can ask me. So that is what. So now, why this power input equals to power not power output? So that is what. So there is a loss in the energy transformation. So there is a loss in power. That's what energy is always loses from transforming from step up to step down or step down to step up. So definitely there is no input equals to output because there is some loss. So that is only what is the causes of loss we are going to discuss now. So energy losses. This is the last concept. So energy losses in transformers. So shall we proceed now? Do you all understand now? What is a step up and what is a step down transformers? Everybody, please respond. So step up means secondary coil, more number of turns. Step down means secondary coil having what? More number of turns or less number of turns? Step down, less number of turns. That is you have to remember it. So first reason, leakage, flux leakage. So if you all notice it, if this is the solenoid, does the entire magnetism is only passing inside or there is a loss of energy? You might be checking. Flux leakage. Everybody, do you all remember it will be similar to the bar magnet? Yes or no, guys? Reflections, please. Everybody. Yes, so that is what. So there is a flux leakage inside the transformer. So that is the reason, that is the cause of okay, so change in that power input is equals to power output. So both the coils you can check it. So what is going to happen? Everybody, I will take different colors and I will draw. So inside it is passing, that's fine. So now then this will be goes like this. Solenoid, we all knows that. Am I right, everybody? Like that only, yeah? All of you. So at the end, what is going to happen? So some flux will be leaking. So there is a leakage of flux. So there is a leakage of flux at the corner. So that is the cause of losses of energy. So flux leakage is the cause for what? Energy input is not equals to energy output. Do you all understand, Ra? Please respond, everybody. Yes, please. Everyone?
Yes, sir.
That is what. So energy input is not equals to energy output. So because there is a loss of energy, flux leakage. So now, to minimize this flux leakage, we are using some core material. What is the material we are using? To minimize this flux leakage. To minimize this flux leakage, we are using a what? Soft, everybody, soft iron core. Understand? So why we are placing a soft iron core inside the solenoid? To increase the magnetic flux. To increase the magnetic flux inside or outside? Magnetic field inside or outside? Everybody, inside. Understanding? So the loss, the flux leakage will be minimum when I am using a soft iron core. So that is the reason we will use a soft iron core. Is it okay, guys? All of you understand? First reason, Pradosh, Mr. Rudresh. Second reason. So now I am using a solenoid. It is a non-insulated solenoid, coil 1 and the coil 2. So definitely they have some resistance or not? Coil 1 and coil 2. Everybody, speak, everyone.
Yes,
Yeah,
sir.
so that is
Yes,
what?
sir.
Resistance. So there are two factors for resistance affecting. Anybody can tell main factors. Of course, 4 we have. So there are two factors. What are the two factors? Resistance is directly proportional to L and resistance is inversely proportional to area of
1 by
cross section.
area cross
Understand?
section.
Yes. So resistance. So because of resistance, so there is a loss in energy. So what is that loss? Joule's law of heating. Everybody, energy loss. In the form of heat, it will lose. What is that? Heat is equals to formula, Joule's law of heating. I square RT. So I square RT. So because of that, some energy will lose in the form of heat. That is the reason of input equals to output, not equals to output. So now, to reduce this loss energy, we have to increase the what? Everybody, increase the length or increase the area? Everybody. To minimize this loss, of course, we cannot make it zero, but we can minimize. So to minimize, we have to reduce the resistance or increase the resistance. Everybody, we have to reduce the resistance. So if you want to reduce the resistance, you have to use the good conductor who is having high conductivity. So who is having high conductivity? Copper. Understanding? So who is having high conductivity? Copper. Because it is having low resistivity. So we all knows that conductivity is equals to what is happening? 1 by resistivity. Is it right or wrong? Yes or no, Rudresh? Yes. So conductivity is equals to 1 by resistivity. So resistivity, what is the unit of resistivity? Ohm meter. What is the unit of conductivity? Ohm meter inverse. 1 by resistivity. Guys, speak, guys. Yes or no? Yes, that's one. So we have to use a better conductor copper wise to reduce the resistance or thickness of the wire. We have to use a thicker wire or thinner wire. Yes, please. Thicker wire. So area increases, resistance decreases. Why? Resistance is equals to what is the formula? Resistivity into L by A. Do you all remember the formula? Everybody? Yes. Everybody? All of you understand? Please respond, guys. So, and we have been proved that voltage increases, current will go into what? Voltage increases, current is going to. Nobody answers. Voltage increases, current is going to decrease, and voltage decreases, current is going to increases. Now, which wire area must be more? Thinner, primary coil or secondary coil? That is very important. So please remember the thick wire on that side, a thick wire on that side where current is high. The thick wire on that side where current is very, very high. So current is high. So that is what. So now if you take now step up transformer. So now tell me step up transformer, which must be thicker or which must be thinner? Current is high. So step up means what? Voltage is increases or decreases from primary to secondary? Increases. So current is high in where? Primary coil or secondary coil? Step up. See, step up means secondary coil voltage is high, so current is less. Now primary coil, what is happening? Step up. So voltage is less, so current is high. So which must be thick wire? where current is very, very high. So step up transformer, which must be thicker? Speak loudly. Primary coil.
Primary coil.
Then step down. So step down means where the voltage is more, current is more. Everybody. Step down transformer. Step down means high voltage to low voltage. So primary coil, more voltage, less current. Then secondary coil, less voltage, more current. So which coil we have to use it in the step down?
Secondary coil.
Do you understand this point, Mr. Prados? For JEE also they will ask you. Rudresh, Mr. Murali, so which coil there must be thicker and thinner? So where current is high, it must be thicker. Where current is low, it must be thinner. So but voltage increases, current decreases. So step up. Step up means what? Low voltage to, please respond. Low voltage to high voltage.
High voltage.
So secondary coil, more voltage. So current is less. So primary coil, less voltage. So more current. So this must be thinner. Do you understand, Ra? Primary coil must be thinner and secondary coil must be, primary coil must be thicker, secondary coil must be thinner. Then step up. Now step down is coming from where to where? High voltage to low voltage. So here voltage is less, so current is more. Current is more. So here must be thicker. That is what. Is it okay, guys? Nothing else is there. Understand, everybody? Yes, that is what. So this is the second reason. Then third reason. Few days before we studied some laws. Hysteresis laws. Do you all remember, everyone? Hysteresis laws. Please respond. I think last chapter. Hysteresis laws. Everybody. Alternative currents. Yes or no? So when the current is keep on changing, then the direction is also what? Magnetic field. Everybody, it is alternating current. So alternating current is remains same or keep on changes direction. Everybody. Even our Indian current, how much time direction changes? What is the frequency range? Frequency of our Indian household, 220 volts, and how many frequency, guys? How much frequency? 50 hertz. So it will change, keep on changes the direction. So hysteresis laws. At least have you heard that word? I am asking. Have you heard the word?
Sir.
Yes. So hysteresis laws. So alternative current. So alternative current means direction is keep on changing or remains same. Everybody. So direction keep on changes. So direction of current changes, then direction of magnetic field also what is going to happen? Everybody. Magnetic field also is going to change or remains constant. The direction of magnetic field will change continuously. Is it okay, everybody? Yes, all of you, Mr. Pradeep, Monish. So what is going to happen? When the current is clockwise or anti-clockwise, you can see that. When the current is anti-clockwise, so direction of magnetic field, you can see that. So it is going to rising up. That is what? Into the way. If the current direction of the current is reversed, then it will be magnetic field also will be reversed. So like that, continuous magnetization takes place, continuous demagnetization takes place, and continuous again remagnetization also takes place, but in reverse manner. So continuous magnetization. Do anybody remember the graph? Continuous magnetization, demagnetization, and again remagnetization. Anybody? Hysteresis graphs. Demagnetization, again remagnetization. So remagnetization in what direction? Same direction, in opposite direction. In opposite sense. Understanding? In opposite sense, it will be changes. So that is what you might be all remember. Now you can remember. So I versus, that is what we can say. So the area of hysteresis loop. So energy loss is always directly proportional to area of hysteresis loop. Hysteresis loop. So you might be remember that. So loop size is increases, loss of energy is also more. Now you can remember the graph. If you all remember the graph, you can tell me. So now all of you able to get it? Hysteresis loss. Everybody? We have done the graph. Yes or no? Nobody says.
Yes, sir.
Magnetization, demagnetization, and again remagnetization. So that is what. So now we have to reduce this area. You reduce the area of what? Hysteresis loop, so that energy will reduce. So loss in energy also reduces. So for that purpose only, we will use what? Everybody. We will use what ion? Speak loudly. Soft ion. So soft ion, if I use it, it will reduces the area of the hysteresis loop. So area of the hysteresis loop is reduced. So that what is going to happen? Loss of energy also going to reduce. Is it okay, guys? Speak loudly, guys. All of you? Yes, please. So that is what. So that is the third reason for, okay. So for what? So loss of energy where input power is not equals to output power. Hysteresis graphs, one time you can see that magnetization, demagnetization and remagnetization in opposite manner. You might be all remember. Yes or no, guys? Check it, guys.
Yes, sir.
So that is what. So area, energy loss, area of the hysteresis loop decreases, energy loss also decreases. That is what you have to remember. Next, eddy currents. Do you all remember we studied or not? Eddy currents. Anybody is there? So eddy currents will be there. So eddy current loss will be happening. So eddy current is also the reason behind for that. As we know that as the current is changing continuously, current changes continuously, then what is going to changes? Magnetic field also. Speak, Ra. Magnetic field also changes what? Changes? Imra. Continuously. So magnetic field is changing continuously. Then what will changes? Magnetic flux also. Magnetic flux also changes. Yes or no? Magnetic flux is changing. Then it will cause us to produce what? Everybody. Induced EMF. If induced EMF is produced, it will cause us for producing what? Or induced EMF is producing, so that it will cause us what? Induced current will produce. So that currents only we say is eddy currents. So these eddy currents, induced current will be produced by, okay, two things. So in transformer, two materials are there. What is the two materials are present? Everybody should respond. What is the two materials are present in the transformers? One is copper coils and another one is what? Speak. One is copper coil and another one is what? Soft
Iron core.
soft iron core. So both the places eddies will form. So one is windings of copper wire. And the second one is material of soft iron. So soft iron core. So that is what. So both will form the eddies. But which is the major one? So that eddies formed in the soft iron core. So generally soft iron core, I am drawing three-dimensional view. You please you have to remember. So three-dimensional view you have to imagine. So it will be three-dimensional. Is it okay, brothers? Three-dimensional, 3D view. Rudresh, you imagine a 3D view. So what is going to happen? Particles are connected from front surface to back surface. Is it right? Speak loudly. Everybody. Particles are connected front surface to back surfaces. Yes or no? So eddy currents are connected from front surface to back surface and they will try to form. They will try to form a large loops when it is a 3D, when it is a three-dimensional soft iron core. So that is what. So they will produce a lot of amount of eddies where eddy currents are very big. So they will form they are actually eddy currents are what nature? We all knows that. Eddy currents are what nature? They are circular in nature. So if it is a three-dimensional one, so see that from front to back it will go, from back to again front it will come, so that they will form very large loops it will form. Do you understand? Speak everyone. So they will form very large loops will form. So that is the currents which we used to call it as eddy currents. So if it is a three-dimensional view, the soft iron core, so front one to back one, it will go again back to next one to next one. Like that, it will form very large loops. So that is what. So let us take the eddy current is IE. Eddy currents in the soft iron core is IE. Okay, so it is actually 3D. Now front to back, back to front and all it is coming. So now let me take the core material resistance. So definitely iron having some resistance. Is it right or wrong? Speak loudly, everybody. So core material definitely have some resistance. So what I can take? The resistance of core material. Let me take it as a RC. Then how much is the energy loss? Anybody can tell? Energy loss is equals to, in the form of heat raw, which is equals to what? Array heat energy, Joule's law of heating, I square, IR square RT. Yes or no? So now here I is what? Eddy's current. So I square into RC into T. So this is what is the energy loss because of eddy's current. So to minimize this one, what we are doing, we are not going to put a 3D, a big iron core. We are going to use the plates. You might be all remember plates, theriyuma? Everybody. So laminated core plates, one plate behind one plate, one plate behind one plate, one plate. Imagine three-dimensional, I'm saying. So in between the plates, we will use some liquid so that it will reduce us the size of the eddy's loops. So it will become two-dimensional plates now. Area. Before it is volume. Now it will turn up into single plate. So we are going to use, okay. So what is going to use it, everybody? Soft iron only. So instead of a single like a block, we are going to use the plates. So plates means what will happen, everybody? Laminated plates. So it is a two-dimensional, three-dimensional. Plates, ra? Plates means what? Two-dimensional they are. Understanding? Huh? So the thickness will be very less. So one plate to another plate. So small eddies will form. So it will be minimizes. Okay. So loss of energy will be minimizes. Because when it is a 3D loops, the eddy loops which will form is very, very big. So the size of the loops increases, loss of energy is also very high. So that is the reason we are using many plates. Hey, do you all understand, everybody? So that is what will happen. The path of the effective path of eddy currents is going to decreases. Means there is no large loops will form. So that is what you have to remember. So the effective path of eddy current decreases. So very small loops because it is now two-dimensional. So plates are very, very small. So in between them, there is a liquid also will use it. That is what transformer oil we can say. So that oil will use it. So actually that is only robberies and all people will take away. So nighttime and all transformers you can see night they will remove and they will take away because very costly it is. And they will use copper coil correct inside. So copper coil they will use for primary and secondary, very expensive. That's why robberies of transformers are extremely high. So this eddy currents will decreases. How? Minimizes. We have to minimize the eddy currents. So how to minimize the eddy currents? To make the three-dimensional block into plates, laminated cores. So along with the insulated liquid in between them. That is what we used to say is transformer oil. So actually, so the liquid laminated core material with insulating between them like a air gap. So insulating liquid in between them. Liquid in between we have to pour. I know because as I'm farmer from the childhood, my father and me, we used to see that when oil also will change. Each 5 years, 10 years will change that transformer oil also. So then only transformers will work efficiently, step up or step down, whatever it is. So generally our motors and all will run with a step down transformers. So basically repairs and all also I know very closely because I used to monitor from my childhood. That's what I'm saying you. So there will be plates which is arranged. Brothers, can you able to imagine? And between them there is a liquid will pour so that it will reduce the what is happening? The path of the eddies. So eddies path will minimizes so that loss of energy is also minimizes. So effective path of eddy currents will decreases. So thus, which will gives us what? Everybody. Energy loss also, please respond. Energy loss also decreases. So that is what we are going to make it. All of you understand? So these are the 4 effective reasons why the energy is lost in transformers. But with the methods, we cannot make it the zero loss in energy. So there will be a minimum. We can reduce the energy loss from maximum to minimum, but we cannot make it into zero. So that is what you have to remember. Okay, guys. So this is what is about the today's class and this chapter. So anybody having any doubt, you can ask me. I hope you all clear with the step up and step down transformers. So then the last chapter in this volume 1. So you all knows that the another most important one where we have many daily applications like MRI scans and all electromagnetic waves. So the majority of the waves what we can see is actually electromagnetic waves only. So tomorrow we'll start. Hardly we'll plan for 5 days. We'll see that at least by August 3rd, I'll finish it and we'll go with that. Okay, guys. 5 days, hardly 6 or 7 days, that's all. So we'll try to finish it. Okay, do you all understand today's class? Everybody clear, Mr. Rudresh? Yes? So this is what is about step up and step down transformers. So very, very important. So please learn. Any difficulty you can ask me. Start working more and wake up early. Okay. Thank you. You can sleep and wake up early. Good night, guys.